I work for Chrome Science. This one. We didn't work 2 hours on the logo, so I was playing with that a little bit. Actually, we do some web platforms for like scientific research programs, European programs. We usually do web platforms. We work in .NET, so that's basically the reason why you are using Windows right now for this lab. Because yes, we were more experienced in this field, but actually for the labs you are free to use whatever you want. I'll use today some data access, so you'll see the entity framework, which is something that looks like Hibernate if you're using Java. Actually, I don't know if PHP has something like this. Yeah, this is a framework which helps you to communicate in this way with the database or whichever kind of data access or data store. Yeah, in Chrome Science we are starting to push very much on improvement of technologies that we use. Like half a day per week we have like free time where we are paid to learn whatever we want. And I think that this was the best choice of the company in the last year or so. Because actually we have time, 1 day per week, to learn whatever we want. And actually, no one more than yourself knows what you miss the most. And I think that, yeah, in Italy the situation is like so and so. Like you heard yesterday from Professor Parenzano, you have sometimes that the company understands only for, yeah, thinks only about the money. So, not good. Okay, so when you're missing something, I'm used to go back home and try to solve it by myself, learn a way to avoid these problems, then go back to work and solve the problems. If your company doesn't allow you this like 1 day per week or half a day per week to learn, take it by yourself, because you will improve much more and you will demonstrate that this is worthwhile. Actually, we started to work with entity framework like not long time ago. So it was like when I entered there, so it's 6 months ago. Till then, we used another technology which is ASP.NET, which is an older technology. It's easier, the ASP.NET, to learn yes, compared to MVC, because it's much more desktop-like and it's oriented to programmers, to drag and drop programmers, let's say like that. While MVC is for real coders, you know, strong guys, and it pushes you to understand really well the concept and what the web is. So the request and response and how to handle the data. So yesterday we learned a little bit about MVC. How was it? Okay, I want to know about you, if you were able to follow, it was too fast, too slow. So who thinks yesterday was too fast? Raise your hand. Okay, who thinks that yesterday was too slow? Okay, just enough? Guys, come on. Who thinks that yesterday the speed was just right? Okay, just right? Good. You already know something about programming. What's your level? Okay, raise your hands if you are just familiar with Visual Studio and some object-oriented programming. Raise your hand if you are familiar with it. Okay, half of you. Not good. Well, let's start. So today I'll just explain a little bit more. You don't have to follow on your Visual Studio. If you want, you can, absolutely. But I'll try to focus more on what's happening. So data access. You have usually you have a database, and you have to access those data. And the classic way of doing it was to send a SQL statement, so a string, to the database management system actually. The database management system will interpret it, compile it on the fly. Actually, it depends. It can be compiled, but it doesn't matter. And then replace with some data. Okay. So the commands to execute was something like that. You had to execute the command with this SQL string, and then you execute the reader and you get back some data. This data is in binary format. So actually you cannot read it with your eyes. You have to use some kind of software to read it, because otherwise we would have to read some strange things. And then you had to interpret the tables that come back to your application and build the objects that you need. Actually, you don't have to build these objects. In ASP, in ASPX or in PHP, you can use those tables to show the data. This is not a very good idea, actually. Sometimes it is, but it's not recommended because it's not maintainable. It's better to encapsulate the data that you get back from the database into objects. So, if you have an object event, it's easier to handle than a table of events with the records of date, time, ID, and so on. Because you can pass it through your application very easily. And you can do manipulation on sets of objects. These sets of objects are can be of different kind and can be indexed in different way. I usually use the list because it's quite easy to understand and to interpret. And yes, this is what you would have to do with the reader. So to encapsulate the object, you have to create like a point, new point, and then fill it. So iterate it. I don't know. In Italian we say to iterate it. So to take the information in like a sponge. You put it in the water and it fills. So this is the object. The object you have to put some data inside. Actually, this work can be automated by the entity framework. And like the entity framework, there are other technologies like Hibernate which can do that. If you're using Java, you should use another one. This is only for .NET. So, with entity framework, actually it takes care of the interaction with the database. So you don't have to think about that. Entity framework just asks the database with the SQL statement, gets the table back, and you use another language to ask entity framework for data. Actually, you use LINQ or link. Link is like, it looks like SQL. So you write a query. You write a query against an interpretation of the database. This interpretation some kind models what your query is, and it makes it, and it queries against the data, whatever the data is. So it doesn't have to be the same database. It can be whatever. It can be an XML file. It can be another kind of file. It can be an object in memory. So this is universal. Once you write a query LINQ, it doesn't depend anymore on the database. You can drop the database and use something else. The important is that you don't touch the objects which represent the data. So you're free to change the technology that goes behind the scenes. And you only use the LINQ to query against this data. So this is an example. You just instantiate the entity framework. The entity framework knows how the database looks like, because when you create it, there is an automatic procedure which reads all the database, creates a representation in memory, and lets you just query the entity framework. And this goes to data, take the data back, run some strange things, some strange code, and gives you back the objects themselves. So LinQ query looks like that. So it's like a SQL, it's a little bit inverted. So from name of the variable in what? The instance of the entity framework, because you have to instantiate it. It's not static. Dot TBL points. If the table in the database was called TBL points, then it would be mapped by default in the entity framework with the same name. And then you say select what? Select point. Select point if you want to select the entire the object which represents the entire row of the table. Now I'm speaking about databases, relational databases most, but actually it can be applied to whatever, to XML, for instance. So this is a very simple query, but here in the middle you can put some order by queries, some parameters, some where parameters, some that's enough, I think. And then take the first or the last or just a range of elements. So to understand a little better, what is the model? So here we have an example of a farm. It's quite nice. We have pigs, ducks, and rabbits. A model is a representation of this real world. Actually, you can have the farm, which has a list of ducks, a list of rabbits, a list of pigs. These are properties. And if you've never seen like C# properties, they are like the getters and setters for the variables in Java. So this is the default construct, which means it's just variable and that's it. Then you have a class for each one of the instances. Here we have duck. Duck has a name and can have some other data, but actually it can have some behaviors as well. Actually you have the quack and fly behaviors, actually methods. Objects can represent more than data. Data is just the beginning. Entity framework by default gives you the data, but by default allows you to implement also the behaviors by extending the same classes that you get out of it. Database can do basically the same, but without the behaviors. You represent only the data. So like in this case, you have a database and you have a few tables. Pigs, ducks, rabbits. Okay, don't complain about the ID. I can give the name if there are any, but as primary keys. It doesn't really matter. The idea is just that it represents only the data. That's it. Entity framework is just another level of abstraction over that. So you have the real world, you present the data somewhere, okay? And then you map them into a model. So your model is easily accessible from your software. Then you access the model, the entity framework model, and it takes care to handle the objects that's beneath. You can build a model in two ways. You have the database first approach, where you already have a database. So if you like to think about database first, you would use this approach. This is the classic style. So sometimes you have to rebuild an application or just implement some new features, and you already have the database in place. So you will use the first the first way of doing a model if you don't have a model yet. You can also mix the classic way with SQL and the entity framework, but actually it is much easier just to let the entity framework map everything and then use just that one. Because it's really fast. You just select the database, select the tables, and the entity framework does everything for you. This one is the new approach, the newest one. You build the model first. So when you're building a new application and you have no idea how are you going to make the tables or how are you going to handle the data, you just know that you need an object which represents a duck. You create the object and you put inside the properties that you need. So yesterday you heard that there's an evolution in software development. Software is not like car building, so it's not about having a full project just perfect and then implement it all at once, because most of the times the projects in software last for a long time, and when you're finished building it, it's already old. So that's why actually we started to build in agile development. So you start building for what you need right now, and you give it to the client in 1 week, in 2 weeks, in a month, not more than a month. In this month, you release a part of the project, and this part should be stable and should be focused only on that part, not just a little bit of features here and there. You should have a complete product, partial product, but a complete, and give it to the client in the shortest time possible, because the client will see the software, try it, and then say, I really don't like this feature, can you just change it? It's not a problem to change a feature if you work on it for a week, but if you work it for 6 months and the client said, this is not really what I wanted, and it's really bad. So actually, you write the code that you need and the objects that you need, and you have the entity framework build your database for you. The database is created with some SQL statements. Okay, so when you're creating a database, you can drag and drop tables and fields from your designer, but you can also write a query, SQL, with create table, name of the table, and then put the fields with some constraints and so on. If you do the code first approach, you build the model. So you say there is a duck, and the duck has a name, a weight, and some other stuff. So you say to entity framework, build a table for me, whatever it is, and he builds the table. And the day after you say, okay, I need some pigs as well. You build a pig, you say to entity framework, rebuild the whole database. Who cares? And he will implement all the tables that you need, whatever the model is. So as you're writing the code, you can, I don't know, you're writing the code and you forgot the birthday of the duck, actually, and you just put it there, and you try the software and it doesn't work, and it says, I'm sorry, but the database doesn't have this field. Okay, resolve it for me, so it's 2 clicks, and the database gets rebuilt, gets migrated from, okay, migration is like another topic we're not going to discuss, but it's possible for the database to migrate the data that you already have, populate the data that are not there, so the birthday that you just put in there, and you have a database up and running. This is good when you have deployment of multiple applications. We, with Promo Science, we have an application which is used by, I don't know, maybe 10, 12 international type projects, European projects, research projects, and it's quite easy that they are unaligned. That they get unaligned because a year ago a client said that he wants a phone book, but we never thought about a Skype account before. So he said, I want a Skype account. Okay, great. And have this application. And this application was built with another technology, not with this one. So what we have to do, we had to put the Skype account field in all the database of all the applications. Because if we deploy an application which handles the Skype account, but the tables in the database doesn't have this field, it would crash. Okay? In this way, you have an automatic way to say, okay, my model is changing. My model changed and gets a new field, which is not required, Skype account. And you say to the entity framework, give me the script to rebuild up all my database at once. And you have all done in 5 minutes. Otherwise, it's 4 hours. So database first. I already said that, so when you already have a database in place, you can just say to the entity framework, okay, try to build it for me, create the instances of the object, and I'll use them. Okay, we'll start with a small demo. So we'll create a database, import it in Visual Studio, and see what has been imported for us. Okay, so we have our SQL Management Studio. This is like the software that you use to see the data on a database environment. So you connect to the database. Actually, we had a server, but yesterday it crashed, and actually we don't have a database anymore. So I had to use a local instance on my computer. This / means that it's on my computer, and this is the instance of the database. Okay, this was the database you were supposed to use, but actually I'm really sorry about that. It's not working. And you have 2 types of authentication. Windows authentication, which use your credential of the credential you are logged in on your computer. So if you are in a domain, in a Windows domain, it works because it allows you to map your credentials to the database. Otherwise, you would have to use a SQL authentication. Right? In a web application, you have your application running with some credentials which are not the credentials that you use for your account. So there are credentials that are used only for the environment where your application runs, which is network service by default, I think. No, it's not by default, but it's better if you use that one. So you should use SQL Server authentication and put your credentials here. Actually, I'll use Windows authentication because it's the option, because I'm the root with my username, and you connect to the database. You can connect to whatever number of databases that you want at the same time. So actually, I built these 2 databases. One, ADS, so it is for Associazione Donatori di Sangue, which is for the project you had to do. And I put inside just 2 tables. So there's the events table. Okay. Let me just explain a little bit how the SQL Server works. Yeah. So you have the tables folder, which contains all the tables, and you have the views. Here you can put your views to modify the tables, to modify how they look to the outside of the world. Yes, till some years ago, to the entity framework came, you were strongly suggested to use views to access your data. Actually, with this technology, you already have a layer in between your application and the data, so it is not that useful as it was. Then you have some programmability where you can put your stored procedures and functions. And then you have a security. Actually, the security needs to be set for each user that wants to access your database. and you have to create new users and just give them login names and so on, and map them to the database that you want to use with them. I'm not going to show this because I'm using the Windows credential to have it work straight. But actually, if you are going to manage some data, you have to. And yes, you have data with diagrams. So I made the diagram just with those two tables. There's a relation between them. So you have the place, which has the ID. The ID has an identity specification. This one means that every time you insert a new record in this table, the ID gets populated automatically for you with an integer number starting from a seed, starting from 1, which is the seed, so the starting point, and incrementing by 1 for each instance, for each record. The same for the events, so this is an identity specification of type int, and then you have the ID of the place, which is int, with no identity because you have to put your own data there for the relation. And then you have the date time for the event's date, and the city and address, which are n varchar of 50 character max. So we have these two tables. I'm going just to save the diagram, but actually nothing changed. And I'm going to create a new project. Okay, I wanted to show you also how to connect to Team Foundation server to manage your code, but we had the same problem with the server, so actually it's not working. When you connect to Team Foundation server, you can see all the projects stored in one only place, and your team can work on these projects with the same code. And you see for each file, each line of code by who was written and when. And you can see all the evolution and all the history of all of your files. So if you see a mistake, you know who did it, and you can go to him and ask why he did that. Okay? Maybe he knows, maybe he forgot, but actually it's really helpful when you're developing in teams, because you're writing some code and then you commit, and somebody was changing on the same time the same file. And so he saw, the Team Foundation server sees that something is wrong, because he compares the two files with the old versions and the new versions, and he sees that something is not good, because you changed the line and somebody else changed another line, and so he asks you what you want to do with those lines. So you can merge them, you can do like drop some changes, take your own, take the other changes, and do whatever you want. And this is really good. You should use it, even for your own application, because sometimes you do some mess and then you don't know how to go back. Okay, and it happens. It happens to the best of you, and you should always care and commit your changes every few hours. This means that you will have a long history for each file, but this is good because you will see how your code is developing. And you can also have a clear separation of the tasks, because you are the developer and you are developing the code, but maybe someone else found a bug. And he can connect to Team Foundation server and say to Team Foundation server, okay, there is a bug, and put the description there. You can just connect to Team Foundation server, you see that there are some bugs and that they are assigned to you. So you start working. When you commit your changes, you attach the changes to the bug solving, so that you know how many hours have you worked on each bug. And this is really, really helpful, especially when you're doing support, and you have to count the hours to make a bid. So we're not going to connect to Team Foundation server right now. We're going to create a new project. Actually, we can we could start with whatever project we want, but still there are some best practices that I would like just to explain a little bit. Like you already heard yesterday, it's better to separate the concerns and responsibility of the code, because it gets more maintainable. So like you saw yesterday on MVC, where you have views, models, and controller, every one of the components have its own responsibility. The views are only like the skin, what you see in the browser. The model is just the representation of the data, and the controller does all the tough stuff. So the controller takes the request, calls the view, takes the model, merges them together, and give it back to the user. With the data is the same thing. So you have to build on layers. You have the database layer, which is the lowest one. Then you start building an entity framework over it. The entity framework is automated. You don't have to worry about that. And then you build a layer of queries against not the database but the entity framework. Always think between like the two layers which are nearby. Don't jump over one or another. So, database, entity framework. Queries to the entity framework, so data as a skill. Then you have the business logic. The business logic takes care about the data that you're populating in the database and makes sure that you're not doing mess out of your data. And then you have your application. Your application could be an MVC application, so you have other layers, but could be a Windows application, could be a console application, could be a Windows Phone authentication, or could be whatever application you want. Just speaking in Windows terms, you have the same in Linux, you have the same in Java. Class libraries are just a packet that you use to isolate the components. So we are going to build a component which represents the entity framework, and only entity framework. And all we build around on the same level. Because as I said, the objects represent the data, but it can also have some other functionalities. So we are going to build a class library which is independent against all the rest, which communicates with the database and gives access to another layer that we will build, which will be the data access. So we'll start with the class library, because class libraries are compiled in a DLL file, and this DLL file contains all the code that gets executed, all in one place. So I don't know how to call it, but let's start with EF model. Actually, it's confusing. I'll call it entities. So it's like the solution name will be, so the solution is the project that contains the solution that contains all your projects. One project is one layer for me. Actually, yeah, for us now, one project can contain just a small piece of your software, and it's better to divide each component that is independent in his own project, because you can reuse this project, this DLL, in whatever application you want. With Team Foundation Server, this is my last 1 month, half day per week research. So when you're building a project, you can use Team Foundation Server to take the new code when you commit it. So when it takes your code, you can configure the Team Foundation server to build the whole application once again. So every time you commit your code, it takes your code, it rebuilds the application, and it can publish the application for you. So you have a continuous integration system. This is good because you're building something, you commit, it takes your changes, it takes the changes of the others, merge them together, rebuild the application. If something goes wrong, it tells you immediately. It runs the test for you, and it says to you, okay, you're missing a configuration file, something is not working. Maybe on your machine was working, but you never know what others have built, or maybe you forgot just to commit one file, and because of that file it won't work again. So it builds everything, it puts the application in your test environment, and you can have your clients access to the test environment in real time. So in 2 minutes from when you say, save my file, your client will see the changes. And this is good. Because agile development is about that. As quickly as you find the errors and what is not working, the better. So, create the directory for the solution, and we are not going to add it to search control because we don't have the Team Foundation server in place. Okay. Good. What's that? What the fuck? Oh. I never saw that before. Okay, so this is the solution. Okay, I'm sorry, I'm using Visual Studio 2012, so it's the 11. But just because I didn't want to reinstall the whole computer for this demo. But actually I'm using the features which are available on the 2010 as well. So I changed a little bit the interface, but nothing more than that. So by default, what you have a solution and you have the class library. This is the class library that we created right now. You have some assembly in the proprietary folder, and you have some references. Oh no, I took the wrong one. Okay, that's why it asked me. Okay, it doesn't really matter. I'll create a new project in this solution. So I can have as many projects as I want in this solution. And this was class library for metro style app, and I will use this one, which is a plain class library. So AES and E. Sorry. So a new project. That one again. AES and E. Okay, and it gets created. So I'll exclude this one from the project. But actually I could delete it. Okay, we have entities. We have a class library, and we have the first class, which is an example. We can just throw it away, we don't need it. Okay, so now we have an empty project. We have some references, so it's Microsoft C#, some system core, system data, system XML, and system XML link view. This is the default, so you get only the default. Now I'm going to add a new item. A new item could be a lot of things actually. We have the visual C# items. I'm working with C#. You can do it with Visual Basic. It's the same. So your code gets compiled in the same assemblies. So you could write in Ruby or in C#, whatever you want, whatever you like most, and they can communicate one with the other. So you can make one project in Visual Basic, the other in C#, and they work very well together. But actually, I'm going to search for entity. Okay, so I found it. There's the ADL.NET entity data model, and I'm going to create the ADS model. ADS model. And I'm going to add it to the solution. And these are the two ways that I told you about. So you have the generate model from database and generate an empty model. We are going to use now the generate from database. So I'm clicking next, and he asks me for a connection. Okay, if you don't have a connection, create a new connection. With the create new connection button, you get this one, this dialog box. It asks you for your data source. So it could be a Microsoft SQL server, but you could change your data source provider so that you could use Oracle or other databases. Okay? You take your server name, so on my computer is ./SQL Express. Okay? I will use Windows Authentication because it's local on my machine, but on the deploy I would use SQL Server Authentication and 3 credentials. Now it's okay. I can choose a database, and I'll take this one, the ADS, the one we saw, and I'll test my connection. It's working? Perfect. Okay. So this is my new connection, and this is the connection string I got straight away. So it creates the connection string for me. What does it say? It says, okay, these are the models that you have to load to have your entities in place, blah blah blah. And it says, okay, the connection string is data source /SQL Express, name of the database, and what is the authentication method. If you specify SQL Server Authentication here, you will get your credentials. So username and password, and this will be stored in your configuration file. You could keep it there, or you could move it away. It's up to you. Actually, it's not the safest place, but it's not that wrong either. So you can store credentials here because they usually get stored. Because they get stored in your application. If you're building web applications, you can put it in the web.config, because the web.config is not accessible to the world. It's only accessible to the administrator. And if they get the credentials of administrator, actually the database is the last thing. I mean, it's not the last thing, but it's the first one. But actually, you're fucked up anyway. So save entity connection in the config file, yes. So with this name, it's okay. And then it gets you to choose what you want to import. I'll take the tables that I need. So event and place. Okay, and I'm clicking finish. So it takes a little time, it reads the database, and it builds the application for me. Okay? So I read the database. You see that the references are a little bit longer. You can see there is the system.data.entity, which is a cloud library built from Microsoft, which does all the things for you. It's amazing. And then, okay, runtime and realization and this stuff. But actually this is the main core of the business. So the system data entity. And you have this model, okay? This model is what you see here, interpreted. Actually you can see the markup, but it's nothing interesting. This is just saying how to display it in this window. So actually it's just the XML representation of this graph. You have two objects right now. These are objects, okay? And these objects have mapped the exact same properties that you had in your database. If you look, okay, there is the event, the ID event, ID place, event date. It took automatically the keys and it built something magic, which are the navigation properties. Navigation properties enables you to navigate from one instance of the object to another. So you don't have to merge two queries together to do the join of two tables. You're just navigating between the objects. Okay? So if you wanted to have like the place where the event was held, you would have to take the ID place of this event and query this table with the parameter of the ID place. So this would return a record where the ID place is equal to, let's say, 5, and you will get the place. With Entity Framework, what you do is just, if you have an event, an object event, you write event.place, and you automatically get this object here. No worries about the ID, no worries about the queries against the database. That they get automatically generated for you. This is the code file that gets generated in this model. So this is the model and this is the code. In Visual Studio 2011, so this one, 2012, you can expand the C# code as well. So I'm going to expand and to see the objects which are in this file. Okay? So you see that the objects are almost the same except for one. So you have the event and the place. So these are objects. And you have an NDS entities which represent the whole system of the entities as the context of the data. So you have the event, and if you expand the event, you can see the properties that you have here. Oh my god, no, wait a second. You can see the properties that you have here, okay? The ID event, ID place, and the event date. But you have also some methods which gets called every time your entity is changing. So if in your code you change your entity, you can trigger this event with these methods. These methods are empty right now by default, so they are not taking care of anything. But if you need them, they are here and you can override them. And then you have the ADS entities, okay, which have some properties. So you have the constructors to just create the instance, and then you have the event and the place. And two methods to add to the event or add the objects to the place. So event allows you to access all the events. It's just a mapping on the table, on the whole set of events, and the place the same. So let's close it. Okay, and go right away in another project. So I'll add new project. And okay, so as I said, it's better if you put some layers in between. So we can make a layer, a class library, not a class library, just to access this code. As you wish. We can do a console application to access the code and to see the examples, or we can build the whole structure. So I'm giving it to both to you. So do you want to see the structure of the application that we use in our company, actually a little bit simplified, or do you want to see the example? So we lose less time. Raise your hand if you want to see the whole structure. Okay, raise your hand if you want to see the example right away. Okay, it seems that the structure is winning. So I'm going to create another class library, which will be our let's say our repository. Okay, so I will call the ID as what? Ah, yeah. Thank you. So ADS repository. Okay? And it's going to be put in the same solution. So now you have to access this data some way. So I'll delete this class. And I have to say to this project, okay, try to look to the other project, inside the other project, and see if you find something. So I'm going to add a reference here, the references, and I'm going to reference this other project. Okay? So I'm going to take my solution and take this project here. Okay? So I got this reference. You see that here you have some other references, like the system data entities, which is not here. So I'm going to add this one as well. So this system, okay, this one, and I need config. So search configuration file to store this information here. Okay, because otherwise it wouldn't know. Ah, no, actually, I don't need this here because I'm going to build another layer. Okay, doesn't really matter. So I can have a new class here, a new item. So I'm going to create search for a class, a simple class, and I call it ADS repository. Okay, and it's going to be public because I want to access it from the outside. And here I'm going to use this model. Okay, so this is AES model, and it's in another size. So I write AES, actually entities, which is the namespace, dot, no, this is the class. I have to write the method. Wait a second. So let's think about that a little bit. Let's populate some data first here. So I'll add a place. So I'm going into the SQL Server Management Studio. I'm going to edit the top 200 rows, the place, and I'm going to put Trieste and EES. Okay, and I'm going to put Trieste once again, and I'll put it. Okay, this is where I work. I did it. RSS box. So you have 2 rows here, and you have an event. So I did top 200. In the new place, the first one will be new ATS, and the date will be. So what's the date? Okay, so it's 9/8/2012. Okay, and one tomorrow. So. 10/08/2012. Okay, so we have list 2 and we have the places as well. Good. So I'll write a method so it will be public. Okay, public get. I'll do it uppercase because this is a convention in C# that you use capital first letter if you are doing if you're writing public methods. So get, and I will take all the events. Get events. Okay. Something is wrong. Return type. Yeah, sorry. This is going to return something which is right over here. So a list of events. I can just return a list or something that represents a list. I would better use interfaces. So I'll return an I, which that is an interface. So yesterday you saw that it's better to program against an interface. Okay, you're seeing nothing. Okay, isn't it a little bit? Actually, it's better to program against the interfaces because you can change the way that you're returning objects. So if I'm going to make I enumerable, okay, this is an interface in system collection generic I enumerable, which this means that the class that you're going to return exposes an enumerator. This enumerator allows you to iterate through all the objects in some way. The iterator, it depends on the structure how it's built beneath, but actually it has always the same result. So it goes from one to the other all the steps. So I'm going with enumerable of what, and I have to give the type, and the type will be what I need. So if I'm going to get the events, I have to get an enumerator of events. So event, okay. Now the event doesn't exist in the current context, but we have this little underscore here, like you saw yesterday. So I'm going to hit Control plus point, and it asks me what to do. So I'm going to use the ADS entities, and it will put the namespace for me. The namespace is a container in which, like this one. So you're saying, okay, if I call something here, it refers to one of these namespaces here. So you can have two different namespaces, and two different namespaces have the same method or the same class. The same class with the same name, actually two different classes with the same name into different namespaces can exist. And you have to define whether you are going to use one or the other with the namespace, which is the full path. So I'm using this one. No, actually, I didn't want this. I want to put it up there. So I'm going to select using ADS entities and put it here for me. So I'm going to return an enumerable of event, and now he says, okay, you're not returning anything. So we are going to solve this as well. We are going to access to the container of the objects. So the ADS entities. So ADS entities is one dot what entities. Okay, I called it the same. It's not good. Anyway. So ADS entities is the container of everything. You're going to instantiate this context, and because it is a context, I'm really creatively going to call it context. And this is the context of the data equals to actually new ADS entities. Okay, I'm going to pass nothing because he knows what to do. Okay. ADS entities. Okay, let me. It's a little bit smaller because I need to switch the color. Okay. Good. So we created the context now. We can access the context. We now don't have to go to the data, so we can go for context and dot and see what is here. Actually, we already created it, and we know that we have some events. Okay. Look to what is inside. We have the event. And we have the place, okay, which is an object set, which are object sets. So this one, you're here, context dot event, okay, dot, and now we got some extensions here. Okay, these extensions are methods built in from the LinkQ class library. So I'm going to select event. No, I'm just going to return all of the events. So I'm calling to list for now. Okay, and this is going to query against our database. And I'm just going to return it. So I'm going to pick return, and I'm returning this one to list. Since this to list returns a list implements the enumerable of the event. Okay? So as you see here, maybe a little bit far, but it returns an enumerable of event. This means that complies to what we said here. And this is going to return all of the events in this context. So now we have this in place. So we have a project which is going to be our repository, and we are going to build to add another project. I'll skip the business logic right now because we don't want to waste too much time. And I'm going to build a console application. I'm going to build a console application because it's easy. We don't have to write the model view the controller. It's just an example. Okay, the tasks. So console application. It will be EES example. Okay, and this one has to access what? We need some references first. So first of all, in the references, we're going to add what? What we have in solution. In solution, we will add the entities because we need the entities. We need event and place objects. And we are going to add the repository as well because we need the methods to query against that one. So hit OK. Okay, it's going to add them. We still miss something. We'll miss. Not this one. I'm going to expand its references. The system.data.entity. Okay. So I'm going to add reference to system.data.entity. This one. Okay. And I'm going to add this configuration. This one to this app config right here. Okay. So in the configuration, you have a start app, you have a connection string as well. This is the one we saw before, and we were creating the object. So we don't need this one anymore. We don't need this one and this one here. Also, we have the main here, and here we can do a console dot write line. Okay, and we are going to pass something. Okay, this something will be the collection. Actually, no, we are going to make a loop and to write the collection of objects that we have. So we are going to instantiate the repository first, and the repository in the method will instantiate the access to data. So the data context. So we are going to say EES repository, okay, dot EES repository, okay. But if I'm going to just delete this one, it would ask me what to do. No, maybe it's not because it's the name of the namespace. I gave unfortunate names, unlucky names. So I'm going to edit it by hand using EES repository. Maybe I can delete it now. So EES repository, and I'm going to call it repository equals to new and EES. Okay, no, it's not going to. Dot EES repository. Okay, we're going to create a new one. And now we can access the methods that we built in the repository. So repository dot. Okay, we have not here, probably is not public. Public class, public, I remember get ans, maybe it was there. Yeah, it's here. So I'm not going to pass anything, we're just going to get the events. This is returning, let's put it like var, okay, nothing, once more. So var, sorry, events equals repository.getEvents. So this var what it means? usually you're used to JavaScript with var doesn't have a strong type. Okay, I wouldn't recommend you to use vars which are not strongly typed, because when you have an object, it is a good idea that you know all that it has inside, and with vars you never know. Vars in C# are different. They are interpreting what is on the other side of the equal sign. So if on the other side of the equal sign you have an IEnumerable of events, it will be an IEnumerable of events. So if I go over with my mouse, it says that it's an IEnumerable of t, okay? And where t is ADS entities.event. So this is an IEnumerable of events, which means that it's something that can return an IEnumerable and an enumerable, and then I can go through the whole enumeration and get all the events. So now I'm going to do just a for each, and I'm going to call it var once again, but just because it's short. Var in what? Events. So this is the syntax for the for each statement. Okay. So here, on each iteration, we have the e, which represent an event in the enumeration. So we are going to hit console dot right line what? E. E is our model, so is our event, and in the event what do we have? We have not only the ID of the event, the place of the event, and the event's date, but we have also the place. And this is what is good, because place is an event place. It's a place, it's not a table, it's not a record, it's not data, it's an object. And it's already there. So we are going to hit to take the event date, okay, and console dot right line once again, and we are going to take, okay, for now just the event date is enough, okay? So we're going to write all the dates that we have in our database, and then read line. Okay, so it waits for us to see the result. And if everything went fine, we should be able to ask in the database, take out all the events and write a line for each event date. So I'm going to hit F5, which means build and give the result. I'm sorry. Where I am? No, I was here. So this is startup project. I'm going to start from here. Start. Okay, so it's right. You can't see anything, but I can assure you that here is the 9/8/2012. Actually, let me download. Okay, so here we are. Okay, so 9/8/2012 and 10/8/2012, and these are dates objects. They are not just text. If you go here in Visual Studio and you want to write like the short date, you go event date dot, oh, I'm sorry, it's running. Good, I'm going to stop it. Dot, okay, this is toString, because it's a nullable, so we are going to cast it into the datetime. Into datetime. And then we are going to say this do short date string. Okay, because we want only the date, we don't care about the out here. So we are going to hit Ctrl F5 this time because I don't want that debug. I want just to show it. So Ctrl 1, and it's the short date time. Okay, so you can take the month, you can take the year. So it's like year, and you are getting only the year. So what is it? You have to use like a method. Okay, yeah, because it's a propriety. Year. So we're going to hit Ctrl F5. It's going to compile it once again. And let it start. But this one is already done, so we can't. Here we are, only here. Good. So now, what do we want? We want to change the model. Okay. I would like it to be. Now, actually, I'm going to do it here by hand. So I'm doing Ctrl C to copy the whole line, and I'm going to paste it in the middle here. And he knows that I want to do this to duplicate the lines. So Ctrl C, Ctrl V, and you're just duplicating the lines. Ctrl X, you're cutting them. Okay. So now I want to access not only to the event, but I want to access to the plate. So I'm going to hit E dot what? Make plate. Okay. Actually, I have to find a way to print this place because the default toString will return just some data about the object itself. But I really would like to have the address and the city. So place, city, okay, and I'm going just to concatenate it. So plus, and I put a comma here just to make it nice. Plus E dot place dot what is it? Address. Okay. So I'm going to hit Ctrl F5 once again, and here we are. Okay. 2012 Trieste, 20s, and Trieste area. Okay. So each one of the event has his own relation, and we are navigating through the relations in the tables just with the object. Have you seen me writing any lines of SQL? Did I a join? I didn't. I'm just accessing the objects. Okay? Now, let's say that we would like our objects, our models, to be a little more, little nicer. So that I want a propriety to have the complete address. Now we build it concatenating to strings. So we have Trieste and area. So city and address. Now we want this to be a propriety inside our objects, because we want maybe to build some other functionality out of this object. So I'm going just to copy it, and here where we have our project of entities, so the lowest level where the entity framework is, I'm going just to make a new class, okay, and call it place. So I'm going to add a new class, okay, I'm going to call it place. Okay, so we have a class place, but in the same namespace we have another class named place. So how can we do that? So this is public class place, but something is wrong. If I try to compile it, it says me that it's missing a partial modifier declaration of the place, because the place here if we're going to see how it's implemented, you have this special word here, partial. Okay? Partial means that this class can be extended in another file. This isn't like Java where you have a file and you have all the code of this object in the same file. You can have it on in different files. So now I could just put another property here. So these are the properties that we already have. So the ID place and the city, which will return a city, but when you're setting it, it will trigger some events, so property changing and so on. We could just put another variable here, another property, and have it work like that. But we don't want it. We don't want it because if we are going to change our database and rebuild the entity framework, it is going to delete all our changes. So we are using our external files to complete this object, to complete the place. Okay, so if this is the class place, no, sorry, this one is the class place, but it's partial. Thankfully it's partial, so if I'm going out of here and I'm declaring this one as partial, okay, this is going to build. So now I'm building and it's built. Okay? Here I'm inside the place, so I'm inside here, inside the place. Okay, and I can put a public property. Sorry, a public property for this place. But I'm going to do the short way, so I'm just writing prop, and then hit 2 times the tab. That is going to create the property, which is of type string, okay, and it's called complete address, okay, and now we have a getter and setter. This is the default, so we can get and set this property as we want, but this is not what we want. We want a private string, which is called like this one, okay, with an underscore in the front just for convention, okay, and we want it to be a composition of the properties that we already have. So the get, so the set will not be allowed. We are going to delete it because we don't want someone to fill in the complete address, because we don't want to split the commas and put one in the city and one in the address, but we want only to get information from this one. So I'm going to implement the get, okay, and the get has to return something. The getters return, okay, something that should be of type string, okay, and the string could just be, okay, now I pasted because I had in memory the line before, like in the console application, but with Ctrl-Shift-D I can have the history of the base. So I'm just holding it, and I'm going to return what? We are already inside the place, so we can just hit city and concatenate with the address and return it. Okay? That's it. We have a complete address. Now we should be able to compile. Ctrl-Shift-D and it's ready. Good. Still compiling. Anyway, if we go into the example here, and instead of this line, we just hit E dot what? Place, because it's a place. And now we can see, yeah, okay, do it now. No, it's not the time. Dot complete address. It's right here in the same object. So now I can just put the control. Okay. Complete address. Okay, I can save it. I can run it. Okay, and the result is the same. The result is the same because we built it in the proprietary. Is it okay? Are you following me?
Yes.
Okay. Who is following me? Who is lost? Who is lost? Raise your hand. Who is not? Okay. And the other? Yeah, you're sleeping. Come on. I'll turn on the light if you want. Okay.
I didn't understand what's the role of that underscore complete address variable.
Okay. The underscore is a convention. This one.
Yeah.
Okay, the underscore is a convention just to say that this is a private string. Okay, okay. I use it now. It's useless because usually when you put, yeah, I didn't thought about that. I'm sorry. I shouldn't be putting this one because this get is already returning something. So it's returning C plus the others. Okay, if we want to have some temporary data, we should use a propriety like this one. So I'm going to copy and demonstrate how it works. So I'm just pasting it in it. And I'm going to call it temp data. Okay, and this is getter and this will have getter and setter. So I'm going to return complete address. No, I'm sorry, temp data. This one. This is just a convention because you don't want somebody to access directly this one. You want them. You need to expose some data. Okay, this is a variable, but it's private. It means that it can be accessed from the outside. Okay. You always want the users who, the developers who access this data to pass through some kind of methods, because in these methods you can trigger events, you can do all the stuff you want, okay, and you are under control always of what happens. If you have to change something about your code, you go here inside and you change the behavior of this method. This is going to affect all the projects that are linked to this project without breaking anything. If you want to change, to access this one and you don't have the data, the getters and setters, but you just put this public, but after a month that you have deployed your application, you realize that someone is putting negative numbers where they shouldn't, and you want to block them, you have no way. You have to redo all the work in the other classes, not to call this one anymore, but to call a method which will control that you are doing the stuff right. So now, just to demonstrate how it works for a propriety, I'm going to return the temp data underscore temp data, and when someone is going to set this temp data, actually I want it to be longer than 2 characters, for instance. So I'm going to write the set method. The set method, I'm sorry. The set method is going to take care of this. So if what value is the value that is passed by default to this propriety, dot length it's bigger than I don't know 2, then I will store this information in my temp data. So temp data equally value. Okay. Otherwise, so else I can just throw an exception. I can do whatever I want. I can just put in the temp data and short. Don't do it. Okay. Don't put this stuff here. This is just an example for you to show, but you should throw an exception here. I should throw an exception. So if the length is over 2, then it's okay. I will put this data in this variable, and when someone wants this variable, I will return the temp data. Otherwise, I'm going to put this string here. Okay, so in my program, I'm going for each event to write the event. Okay, I will So this is on one line. Okay, I'll just show you the result. Okay, I forgot to close this one. Okay, oops. So we don't have 2000. What happened? So that's right. Yeah, okay, that's the right line. Got it. Let's see if it's working. Okay. So I'm going to put here in each year console.writeLine, an empty line. So to divide them. And I'm going to put here complete address and the temp data, okay? Okay, if you see here, I cannot access the temp data proprietary, the temp data variable. I had to use the temp data because there are no variables put out for. So I'm going to take this temp data and write a line. Okay, this is going to return a null, so I don't know what will happen, but probably will not work. So I'm getting an empty line. Okay, then I'll try to just put in e.place.tempData equals to a. Okay, I'll put an a, and then I'll try to see what happens. So when I run this one, okay, it says errors, this is too short. That's because of the control we did with the input data. So you're using this method to control what's happening in your properties in your data, and you can use it whenever you want. So this was the place. Any other questions? Who was the last one? Okay, tell me.
A question or?
Yeah, what you didn't have? Anything?
Well, it's hard to make a question if you're lost. But,
Okay, well...
this is a new technology for me. I've never used Visual Studio, so...
okay. So this is basically the concept. So you have these two projects. Okay, the entity is the repository, which is just calling the entity framework, and then you have the example, which is what uses the objects that are taken from the database, or whatever is designated. So I'll try. Oh, okay, time is almost over. We can put some data inside. Okay, so we are going to go to the repository, take the same repository, and now we are going to try to insert a new place. We're going to insert a new place because if we are going to insert a new event, it is going to ask for a place because it has a foreign key. So I'm going to put public and I'm going to return the place, because when you're inserting the place, you don't know the ID of the place yet. You will know the ID of the place when you get the object back from the database, because the database is deciding the ID. So public place, it's okay for the convention, okay, and I will just take inside here a place, okay, so this is the place. And we are going just to say to the context. Yeah, now you see, we have to use the context once again. there is an easy way around of instantiating it on each time the same repository, which is using what we already saw now. So I'm going to put it here, but I'm not going to instantiate it now. I'm just going to wait. Okay, this is private. Okay, context is private, and we have private as well because we don't want to be asked from the outside. ADS entities with the get and set. So get. Actually, we don't have the get. Okay. Okay, this is context, and this is underscore context. Good. So the get should just see if the context is not null. So if the context, so we put an equal null here, to show that it's null. If context is null, then you have to instantiate a new one. So we'll put into the context what I'll use the history, Control Shift V. Okay, new alias entities. With the underscore, this one. Okay, and then I'm going to return the context in any case. So return the context. So the getter will work in any way. I'll never have to do this one in my context, in this class, because this is creating the entities on the fly. So I'm going, when I need to insert the place, I can just access the context and say to the places, okay, that I want to add an object, and this object is the place, which is passed to this one, and I want the context to save the changes, okay, and then I'm going just to return the same place, okay. So this is the code that you have to write just